what I'm doing in this demo is I have a SmolLM 2, an LLM, which is working purely on my browser. And what I'm asking the model to do is take an issue, which could be anything, could be a GitHub issue. In this case, it is the login page is not properly handling passwords. And what I'm asking the model to do is to create like a JSON or like a structured output based on this information. And I define what the schema should be like. So it should have priority, it should have a GitHub issue, description, labels, and so on. And hopefully when I click on generate structured issue, I will get like some sort of a structured sort of output of this over here. And the idea behind it is to showcase that these models are actually quite capable. You can build like pretty cutting edge stuff just by really simple small models running locally. In this case, it doesn't even cost you anything to host this model because all the computation happens on the user side.
Good morning, good afternoon, good evening, depending on where you are. We have people spread across time zones as special guests today, as we usually do, all of us learners in this session. I'm really excited about this one because I do a lot of local model stuff, but none of my local models example code is at all pretty or clean or usable by anybody else. I'm absolutely convinced that we're going to move towards hybrid local and cloud architectures for everything we do in real-time AI over time. One of the very first public PipeCat sample code things we wrote a very long time ago was a Moondream visual model paired with GPT-4 before GPT-4 had any image input, I believe. This is probably, I don't know, Chad, if you remember, maybe like mid-2023.
I was going to say it might have even been GPT 3.5, but it was because we had some early PipeCat demos that were, even prior to GPT-4.
There's so much great open source model work and so much great multimodal open source stuff happening. So I invited people whose models and ecosystems I use to show us what they're working on, what they're excited about. And I will just let them introduce themselves because they'll do a way better job than I will. Quick reminder, as always, please chat mostly in the Discord. That lets us keep the chat going, lets us thread the chat. We will gently nudge you toward the Discord if you chat in the Zoom chat. We say that every time. And I think that's the only announcement other than that I am working on finishing up the credits with all the sponsors. Thanks for being patient. We will get all the credits issued pretty soon. Without further ado, I will throw it to Vaibhav for a self-introduction and then an audio ecosystem on Hugging Face overview.
Perfect. Hello, everyone. I'm going to keep it light and breezy. Who am I? VB. You might have seen me on the internet by reach_VB. I lead on-device platform community at Hugging Face. I am a local LLM enjoyer. I spend a lot of time on local llama on Reddit. And what I do for work is essentially build glue work, essentially make open source tools work together and better. There is a demo over here just to showcase like what is possible with local models and so on currently. Funny enough, it builds on WebGPU. Hopefully this would work. And essentially what I'm doing in this demo is I have a SmolLM 2, an LLM, which is working purely on my browser. And what I'm asking the model to do is take an issue, which could be anything, could be a GitHub issue. In this case, it is the login page is not properly handling passwords and so on and so forth. And what I'm asking the model to do is to create like a JSON or like a structured output based on this information. And I define what the schema should be like. So it should have priority, it should have a GitHub issue, description, labels, and so on. And hopefully when I click on generate structured issue, I will get like some sort of a structured sort of output of this over here. Again, this is a really small model. It's like a 1.7B model. There are no APIs involved. Everything is happening directly on your browser. Hopefully it doesn't take ages to, okay, it's fast enough. And the idea behind it is to showcase that these models are actually quite capable. And you don't really need OpenAI sort of GPT-4 or O3 Mini, whatever new latest model by either Google, by DeepMind, or by Anthropic and so on. You can build like pretty cutting edge stuff just by really simple small models running locally. In this case, it doesn't even cost you anything to host this model because all the computation happens on the user side. So in this case, what happened was that the model sort of was downloaded, also cached. So next time that you use this, it would be much faster. And it generated a schema or it generated a JSON output based on the given input, which is there. And this is how it looks like in preview. And I like to believe that this is like a really nice example of how what these models are capable of now. So now that we've seen like what a snapshot of what these models are capable of, how does one actually run stuff like this? There's actually like a huge array of like tools, apps that you can use. There's Transformers.js, there's llama.cpp, there's Ollama. So starting with like starting one by one, there is one of the biggest sort of local players, which is llama.cpp, which has like a huge wide variety of libraries as well as apps. So there's Llama.File, Ollama, LM Studio, PocketPal, Llama CPP Python, also Comfy UI. Then there is MLX ecosystem. There's, of course, the MLX LM, MLX VLM, MLX Audio, which Prince is going to talk about in a bit as well. And then there is ONNX runtime, which has a lot of runners, the most prominent one being Transformers.js. Then there's ONNX RS, ONNX PHP, and basically ONNX for each language. And then there is TVM, which has MLC LLM and WebLLM. The demo that you saw just before for structured generation was based on WebLLM. It's a library which I personally use quite a lot for my fun projects. There is whisper.cpp, and there are quite a few apps and actually paid products built on top of whisper.cpp, same as llama.cpp as well, which the two big ones are Mac Whisper and Super Whisper. And then, of course, there's VLLM, TGI, depending upon like how you use them. You can use them for local use as well if you're predominantly in a CUDA-based setup. And essentially, like all of these apps, libraries, and frameworks can help you build either audio-based demos or LLM-based demos, and so on and so forth. And you might ask, what's like a typical workflow of running these models on device? Of course, I'm from Hugging Face, so I'm a bit biased. So you would typically go on huggingface.co. You would select a model. Let's say you select DeepSeek R1 Qwen 1.5, and then you essentially start chatting with it. For example, you can use llama.cpt. In this case, you can use llama CLI or llama server and just provide the path to the model. Similarly, for Ollama, you can do llama run and then the path to the model itself. And in most cases, it should look like something like this. And this is just for like LLMs. You can do something similar with whisper.cpp when it comes to audio and so on. Some quick facts about the usage of on-device models, be it like LLMs or audio and so on. At any given sort of month, we experience multi-billion pulls, meaning like multi-billion sort of downloads or cache checks on the Hugging Face hub for these on-device models. There are roughly 200K plus LLMs. These are just public, so I'm assuming the private ones are 300K or a bit more, just an assumption. In terms of GGUFs, which are like from Llama CPP world, there are 80,000 optimized Llama CPP or Ollama compatible GGUFs on the hub. And on any given day, we're roughly getting close to 6.5 petabytes of egress in terms of pure bandwidth, which means there's a lot of appetite for these models. And how do we contribute? Of course, there is the Hugging Face Hub. There are our core libraries, which is transformers, tokenizers, Hugging Face Hub, which you use to interact with the hub. There are our specialized libraries. So there's Optimum for ONNX, Neuron, TRT-LLM, and so on. This is what typically downstream runners like Transformers.js and ONNX RS and so on use to then create like a WebGPU or just like demos or production-based piece. We have specific on-device libs. So there is Mistral.rs, Candle, Transformers.js. We are also contributors to llama.cpp, also to MLX, and so on. I would end this sort of quick presentation and overview with what am I most excited about next. I'm quite excited about llama.cpp, essentially embracing multimodal quite a bit. So there's like audio support, which was recently merged as soon as like yesterday. And that's something which I'm quite excited about, which means that you can play around with like end-to-end models like Qwen Omni or 5.4 multimodal and so on. This opens a lot of possibilities for demos, apps, and so on. I'm quite excited about Transformers backend. This is something which allows you to have one model definition of the model itself, and then can be plugged in TGI, VLLM, SGLang, and so on. This is something, again, we're actively working on. This is already live in TGI, already live in VLLM, and should be live in SGLang within a week or so. Then something which I've personally been spending a lot of time of late is with model context protocol, and especially in context with local models and how you can use it to automate certain workflows and so on. And then, of course, like the evergreen, which is more accurate quantization schemes, something which MLX is doing quite well with the recent DWQ quantizations. And of course, leaner and easier packaging across all the libraries. That's about it. I know this was like whirlwind tour, but hopefully you learned something about the overall ecosystem, and more than happy to answer any questions.
Yeah, I think that's fantastic. There's so much stuff in Hugging Face's very broadly defined ecosystem that figuring out which threads to pull on is its own journey. I think this is a very helpful orientation. I'll ask a question that was posted in the Discord and then a couple more questions just to help orient people and me. Somebody asked, the LLM in your demo, was it running in the web browser?
Yes. So this, like, the model is runs in the browser. So not over an API, no nothing. It uses the LLM from MLC. In fact, Joshua, who would be talking about WebGPU quite a bit, I hope in a couple minutes or in an hour, would be talking quite a lot about the same as well.
No, that's great. And so the person followed up on the question that you can also run a browser and then Ollama on your local machine and connect through a local network. Yeah, local host. But in this case, you're actually running in the browser.
Yeah, I think there's like one thing to note here is that this is something that you ideally want to, if you're building a product or if you're building like some workflows wherein a lot of different users are involved, the most ideal state would be to just have a model be powered by WebGPU, because then you essentially save on the cost. You also save on any issues with respect to deployment of a model and so on. Just note that like WebGPU still is like quite bleeding edge. There's quite a lot of support coming in. It only, for example, works on Chrome and like certain other browsers. It fails to work on Safari half of the times and so on. But as it gets more mature, you would see a lot of simple tasks be offloaded on the browser.
Is there a model size limit based on WASM architecture limitations, or is that old knowledge that I should update?
I think as far as I remember, like there was like a 4 gigabytes limit, but a lot of work which Joshua has been doing on Transformers.js side and so on, I think there are ways to circumvent that. For example, with MLC, WebLLM, you can, if your browser allows, or if you have enough VRAM, you can even run llama.cpp directly on the browser. It would take a lot of time to download the model. In theory, you can.
When you're outside the browser and starting to run models locally, one of the, I think, things that is a little confusing initially to a lot of people is there's the llama CPP ecosystem, there's the ONNX runtime ecosystem, which is also relevant to the browser, but we'll leave that aside for the moment. How do you point people when they're like, oh, I want to run some LLMs on my machine with a NVIDIA card? Do you start with llama CPP? What do you do about ONNX runtime?
I think my personal rule of thumb is if I'm on like a Mac device, then I typically always use llama.cpp. You can just do brew install llama.cpp and then just essentially go on the hub and let's say, oh, actually I should just search gguf. And you essentially have any of the models over here. You can just use them. And like over here, it tells you whether or not it is compatible with your model. And then when it comes to CUDA runtime, I think like you have a lot of options there, and it depends on what you're using. I still use llama.cpp or interchangeably VLLM just because it's so much more sort of Pythonic to use. But then again, it depends on what paradigm you want to use at. I know that folks at local llama also use EXL and a bunch of things, but I think I like to keep things easy and just use VLLM for CUDA and llama.cpp for my Mac.
And can you give a short intro to quantization and how that works when you're climbing up the local model's learning curve?
Sure. So quantization in a loose term essentially means that you have this concept of linear quantization, which essentially means that you essentially remove bits from like individual bits that you then multiply and then essentially get the final like output. You essentially reduce them so that you reduce the storage or like the size of the model. So for example, in this case, this is Qwen3 30B A3B. In like pure BF16, this would be like 61.10 gigabytes. But then if you go down to Q8, which is like 8-bit, it would be half of that, which is like 32.48, right? And this is still quite high quality. You don't really lose as much accuracy. And then as you go down, you start becoming more and more aggressive with respect to like how much information do you remove from all of these like individual sort of tensors. And the way it works is that you would remove information and then you would create another sort of matrix, which you would then multiply and so on. We can go into that a bit later if you want to, but the broad level idea is that you reduce the amount of data that is stored in like each tensor. And the lower it is, the lower the accuracy would be as well, but the lower the size would be as well. So typically what people do is if they have a model that they want to run, they would go and look for a table like this on like the model card on Hugging Face and then see how much RAM they have. Let's say like my Mac has, I don't know, 32 gigabytes of RAM. So then I would choose the one which would just fit. So in this case, I would choose Q6KL. It is 25 GB and it works and so on.
So I'm going to ask a dangerous question that would create flame wars on our local llama. If you have a choice between running a smaller model at a bigger quant or a more quantized model that has more parameters, what do you do?
I typically use the largest model that I can get at Q4 and above. And like typically I don't go below like Q6. Of course, if I'm dealing with really large models, then I can go down to Q4KM. Q4KM is like the default in Ollama, which for a lot of reasons should work. But of course, because it's like a aggressive font, like it could be that you get like not as good quality. And so I like to have a lot more control. And yeah, so essentially like Q6 or Q8. So yeah, larger and the largest I can fit at minimum Q6, essentially.
No, that's great. Thank you. Last question, I think, pulling out of Discord is, do you know of a browser control model that you can run in the browser, like a computer use model that can control the browser from inside the browser?
Oh, wow. Okay. I actually don't know much about it. I have seen demos, but I really don't know much about it. Maybe like later on, Joshua can comment on that. But yeah.
That sounds great. Thank you so much. We will switch over to Omar. I will just do the segue by saying I saw Omar's really fantastic talk at Google I/O last week. I was sitting in the talk. I realized there were some new MLX quants for the Gemma models that Omar was talking about that I hadn't tried yet. I started pulling those models down to my laptop while watching the talk because, of course, it's Google's Wi-Fi. I figured it was going to be fine. I had my notifications turned off on my laptop because I didn't want sound to play while I was sitting in the talk. An hour later, I looked at my notifications and AT&T had sent me a bunch of notifications that I had completely used up all of my mobile data for the next 10 years because I had fallen off the Google Wi-Fi at some point without noticing. But I got a lot of cool Gemma quants for it. And Gemma's a super fun model, and there's some new stuff in the Gemma ecosystem. So over to you, Omar.
Yeah, so sorry about that. Cool. So this will be a very brief talk. I'll talk about Gemma. And if you don't know Gemma, Gemma is the family of open access models that Google has. So these models are built on the same research as Gemini. But the models are open, and that means that you can run the models locally, and we really focus on making sure that these are the best models that you can run in a single consumer GPU. So that means a GPU that you may have at your house. So we released the first Gemma model a bit over a year ago. That was around March of last year, maybe a bit earlier. And since then, the core Gemma models and all of the Gemma models that you can, Gemma-based models that you can find on Hugging Face, Ollama, and Kaggle, they had over 150 million downloads right now. I will be very brief, but there are a bunch of Gemma-based models. So there are the official models that Google has released. So those are Gemma 2, Gemma 3. We just announced Gemma 3N last week. There are some variants with a specific, so PalyGemma for some vision tasks, Code Gemma, it's a bit old by now. There's Shield Gemma and Shield Gemma 2, which is more for safety applications. We also released MedGemma last week as well for medical understanding. And we even have a Dolphin Gemma model that will be shipped later in the summer. And it's an actual model to do Dolphin to Dolphin generation. So it's like a Dolphin next token prediction model. And apart from that, we have released a bunch of different open source tools, such as llama.cpp for on-device execution. So I'll talk very briefly about Gemma 3. And by the way, I'm not sure if I can hear you. So if you say something, please just put that in the Zoom chat. But yeah, so for Gemma 3, we released 4 different model sizes. So 1 billion, 4 billion, 12 billion, and 27 billion parameters. We focus quite a bit on the model range under 30 billion parameters. That's what can fit in a normal consumer GPU. I know some of you may have the latest, super fancy, very expensive GPU, but 99% of people don't. So that's where we are trying to focus. So we released 1 billion text only model, and then 4 billion to 27 billion that are multimodal long context models. So yes, I mentioned it's multimodal input. That means that you can pass as input text, images, and videos, short videos. It's extremely multilingual. That's something where we focus quite a bit. We're using a tokenizer based on Gemini as well. So it's a heavily multilingual tokenizer that works for 140 languages. And we are seeing many research labs that are also fine-tuning Gemma for their own languages. And the fact that the tokenizer was trained with a good data mix for many languages really helps the model generalize to other languages as well. For Gemma 2, one of the main feedbacks that we had was that the context was very short. That was because it was just 8K tokens. So we increased to 32K for the 1 billion model and 128K for the 4B to 27B models. So that's roughly 400 pages of text, 500 images. For on-device execution, long context, very long context is not that interesting in the sense that the longer the context, the more GPU you're consuming. So usually 32K should be enough for 1 billion parameter model, because then you're running those models in a phone and you don't have unlimited GPU compared to a server-side model where you can probably have a 100, even 200K tokens as input. So this is a very nice plot that shows the perplexity, and perplexity is a measure, the lower it is, the better. And this is for Gemma 3. What you're seeing here is the dotted lines show the perplexity for the 4B, 12B, and 27B. And the normal lines, those show the perplexity, but for the same models with an additional long context training stage. And as you can see, for those models trained with the extra long context, the perplexity remains low, even at a very long context. Then it explodes and goes up again. But officially, Gemma 3 supports up to 128K. But if you look closely at this plot, you will see that the context actually keeps going quite well, even up to 256K. The supported context is actually quite a bit longer, but 128K is where we did most of the testing, but at least perplexity testing shows very nice results for very long context. And all of these features, once you combine multilinguality, long context, multimodality, you can do cool stuff. So you can pass images that have text in multiple languages. You can ask the model to do things such as translate or do understanding. The model can work quite well in this kind of weird multilingual, multimodal setup. The way we did Gemma 3 has been in a very community-driven way. So we have been asking a lot in local llama, in Reddit, Twitter, open source developers, companies, startups, researchers were asking what they want for Gemma for the next Gemma iterations. We are trying to incorporate all of these features back to the next iteration. So if you're already playing with Gemma 3 and you have any feedback, we incorporate that for the next version, right? So if you want to see anything in Gemma, the next Gemma models, please just reach out to us. We are incorporating all of this feedback. And here you can see the LLM Arena score. So LLM Arena is not a perfect benchmark, but it's one of the best benchmarks we have to assess as a proxy of how much people like different models. So this is really a human preference arena or benchmark. So how it works is that you type a prompt, you get the results of 2 different models, but this is a blind test, so you don't know which answer is generated by which model, and you pick your preferred answer. And once you aggregate that over hundreds of thousands of people, of submissions by different people, you can aggregate that into the LM Arena, so you can have the ELO score for different models. So this image here shows different open models. So this is only open models for different model sizes. So the number is maybe a bit slow, but you can see it says, for example, for Gemma 3, here we have the 4B, 12B, and 27B. And then the white dots at the bottom is the number of GPUs, H100s or A100s that would be required just to load the model in half precision. You can, of course, do quantization. So you, let's say, can go down to 8 bits or 4 bits, and you can then maybe reduce by half or by 4 the number of GPUs that you would need to load the model. I think in the context of the people joining this call, you're mostly interested in single GPU models for local inference, unless you have a very nice setup at home. So in those cases, Quen has nice models. V models are also nice for their sizes. But at the end of the day, what matters the most is which is your use case. So really just playing out with the model and finding out which is the model that works the best for you is the most important part. And again, we really focus a lot on multilinguality. So this image is maybe a bit outdated. This is back from March. But if you search for Gemma at the left, you'll see Gemma is at the middle, a bit below. But Gemma works very well for French, Spanish, Japanese and Korean are 2 areas where we have been focusing quite a bit, actually. So yeah, it's also important to, especially if you're deploying models in actual production setups, to make sure that you can build global products. So something that we care quite a bit. And we have been working very closely with many open source developers, with Hugging Face, with Ollama, with Onslaught, with the LLM folks, with many different open source contributors to make sure that when we release a model, it's really accessible for all of you to choose. And we are trying to do day 0 integrations into most of the favorite open source tools of the community. And just last week, we announced the Gemma 3N preview launch. So this is not a full launch yet. We do not have full open source integrations. We released the model in 2 places. So AI Studio, which is hosted in a server, and MediaPipe, which is a library by Google to run models locally in your phone, in Android. And there's a package that you can install in your phone to try out the model. But we will do like a full release in a couple of weeks, working with Ollama, Onslaught, Hugging Face, and many of the other open source contributors. Gemma 3N can run with 2 gigabytes of GPU or 3 gigabytes, and I'll talk a bit more about when to use which. It's really optimized for on-device, so there are many architectural differences compared to the previous models. And we expanded the multimodal understanding, so the model can also have audio as input. And the model architecture is a 4B matformer architecture, so that's what I will mention. I will talk a bit more in a minute. And it has a submodel within the 4B model of 2 billion parameters. This slide is actually wrong. It's 2 billion parameters, not 1 billion. Let me try to show a video. If you can tell me if the audio works, that would be fantastic.
What do you know about this replica?
Perfect. Just before I show the video, this is a video of Gemma 3N running in a phone in airplane mode. So everything that will happen now is entirely offline. That's why sometimes it will be a bit slow to respond.
What do you know about this replica?
This is a replica of a Virgin Galactic Spaceship One aircraft. It's a cool piece of aviation history. Spaceship One was a company that aimed to provide space tourism experiences.
What kind of plant is this?
That's a Monstera deliciosa. It's a beautiful tropical plant known for its distinctive split leaves. They're popular houseplants because they're relatively easy to care for.
How often do I have to water it?
Water your Monstera every 1 to 2 weeks. It's best to let the soil dry out between waterings.
What does this function do?
This function calculates the number of ways to climb end stairs, given that each step can be either 1 or 2. It uses recursion with memoization to avoid redundant calculations.
So that's pretty much what it does. This was a bit of a unoptimized video that we did a few days before I.O. Actually, if you go to the Gemma 3N launch blog, you'll find like a new video with all of the optimizations. It's actually much faster than this. And you can do cool stuff with translation, switching context, that kind of stuff. I mentioned that the model has this weird architecture that you have probably never heard, which is called matformer. This is a 4B model that also has internally another 2B model that you can just extract. And what is cool is that you can use either the 2B model or the 4B model, but there is this thing called mix and match, which allows you to pretty much use any model size in between by being able to load some of the layers. What you can see here in this plot is that on the x-axis, you have the number of parameters that are active. On the y-axis, MMLU, which is one of the popular knowledge-based benchmarks. And then you can see what can happen if you grab models at different sizes in between the 2B and the 4B. It's a very nice curve and what that means for you as a on-device user is that if your local use requires a 4B model, or if you don't have that much compute, you can really play with this trade-off of different model sizes. So there will be much more information about this architecture in the next couple of weeks. There's a paper for Matformer, so it's not a new model architecture, but it has not been done out there in the OpenML ecosystem. We release some utilities also to play out with this mix and match. Yeah, it's a very nice thing. I will not talk too much about the architecture now, but feel free to go to the documentation. It is early stages, but we have cool things to share. I think that's pretty much it. I had 2 slides for quantization and QAT, but Bibi already talked quite a bit about quantization, so I think we can skip that if that works.
No, that's great. Thank you. Excited about Gemma 3N. I didn't actually know that Gemma 3N has native audio until pretty recently. Can you talk at all about the audio architecture for Gemma 3N?
We'll release a paper for this in the next couple of weeks. Same for the vision side of things. Actually, the vision is quite nice. But yeah, for audio, what we have is a multilingual speech recognition. We have a speech to translate the text, so you can talk in one language and then get text in another language. And then you have some speech understanding capabilities as well. That's a high level of capabilities. Model architecture, we will be sharing a bit more soon.
And it'll be an open weights model, just like all the other Gemma family models.
Yeah, exactly.
And the
idea is that these are the models that will be able to run directly in Chrome or directly in Pixel or Samsung phones, as an example.
Are there any other publicly disclosed audio plans for the Gemma family?
Not at the moment. I think for us, what is important is to get the Gemma 3N model in the hands of people. And then, as I was saying before, we are developing Gemma in a community-centric way. So our goal is to get as much feedback as possible on what people like or don't like about the new vision capabilities and about the audio capabilities that we are just releasing now. And then based on that feedback, we will iterate for the next Gemma models.
Another question from the Discord, is OCR a use case you benchmark and hill climb on?
OCR is definitely something that we focus quite a bit, especially making sure that it works well across languages. OCR capabilities for Gemma are quite good. If you ask me what does Gemma don't do well at the moment for vision, things such as image segmentation or object detection, those are capabilities that Gemma currently does not have for vision, and those are things where we do want to iterate because that's something that many people have expressed interest. So yeah, localization, understanding, like pointing, counting, that kind of stuff, right now it does not work super well. So yeah, we will improve on that.
From a research perspective, is there any architectural limitation there, or is it just data set and training?
I think it's mostly data set, really data set training, benchmarks that we focus, that kind of stuff.
Somebody asked what the numbers in that grid of languages meant.
Yeah, 1 second. Let me share again my screen. Be very quick. Yeah, so this is from the LM Arena as well. Pretty much they have a range in which they would determine that there are multiple first places or multiple models tying in the second place. So that's what these numbers mean. So for example, if you go to Gemma, what you can see here is that it's the 6th place on English, 4th place in Chinese, 2nd place in German, 1st place in French and Spanish, 5th place in Russian, and so on. Again, this is from March or April, this is screenshot. So it may be it's mostly outdated. So Gemma is probably like 2 places below where it was for the launch.
Somebody asked, thanks, that makes sense. Somebody asked about the 4B and 27B models having similar perplexity with large context compared to the 12B on your slide. Is there any kind of reason for that or way to think about that? Maybe especially in the context of like multi-turn stuff we do with voice.
I think for the 3 models, we see a very similar pattern. I guess maybe for the 12B model, the explosion is a bit larger, but I wouldn't think too much about the different ways in which the perplexity exploded from one model to the other. Multi-turn wise, though, I would be surprised if you go above 200K especially in the local context, because again, the VRAM will begin to explode. The QB cache just begins to grow a lot as you go at a very large context, and things will become very slow. If you're going above this context locally, please let me know, because we haven't heard any feedback of people asking us for longer content. We got some requests for people that host models server side, but if you're a local user that is using like extremely long context and you're able to handle that locally, I would love to hear which is your use case. That would be interesting.
For those of us in the voice world too, longer contexts tend to increase the latency of each inference calls. So it's a tough trade-off. Somebody commented that 27 billion parameters on a GPU you have at home is not something they thought they'd hear. But on the other hand, on the MLX machines, we tend to have potentially a lot more RAM now than you do in the NVIDIA ecosystem. How do you guys think about things like the NVIDIA ecosystem, MLX, the Pixel phones, maybe the GPUs that are in the Raspberry Pi? Are you trying to target everything?
Yeah, pretty much, yes. We do want to target all consumer GPUs, so we will not be releasing models. Most likely, we will not be releasing huge models that require dozens of GPUs to host the model, but I think this plot is a good one. This is a number of parameters, amount of GPU that you need just to load the model for these different model sizes, and this is just like a rough napkin math thing, so you pretty much multiply by 2, and that's what you would need for half precision. But as Vivi was saying, you can do things such as quantization that allows you to significantly reduce the number of bits to store those parameters. And hence, if you have a GPU of over 15 gigabytes, you should be able to load the 27B. Personally, I really like the 12B. 12B you can load with 7 gigabytes of VRAM. That's something that many gaming computer, I think most of you probably do have a GPU, even like free Google Colab, you can run these models, right? So it's a very accessible model. But that said, of course, then there's also like actual robotics applications, and we have some work streams there. So we have the 1 billion model, and we may explore smaller models as well in the future. And this matformer architecture is also trying to explore a bit what we can do to enable devices with different compute capabilities. One thing that we did for Gemma as well, and the image is pretty much saying the same thing as the table in the previous slide. There is this technique called quantization aware training, which is pretty much, so you pretty much have the trained model, and you do a very small additional training stage with just a couple of thousand of examples, maybe 5,000 examples. And that can make your model much more robust to quantization. So as Vivi was mentioning, if you do quantization, the quality may begin to degrade. So if you go to 8 bits, it's usually fine. If you go down to 4 bits, you may start to see the quality going down. And if you go below 4 bits, then the quality becomes a bit gibberish sometimes. Depends a bit on the model. But if you do QAT, then your model is much more robust to certain quantization schemas. So for example, if you do a QAT for Q40, which is like one specific quantization schema, one way in which llama.cpp and MLX allow you to quantize a model. Then when you actually apply this quantization method, the model quality will not degrade as much, or will degrade just a tiny bit. So this is like an additional training stage that makes the Gemma models, let's say, maintain the quality even if you go down to this very small number of gigabytes for VRAM.
Historically, there were lots of quants by people in the community outside of labs. For quantization-aware training, you have to do the quants. Is that right?
You can. So pretty much what we did was, just to share a bit, so the way you do QAT, you are applying quantization or simulating quantization during this additional training stage. Then what we have released on our site was the unquantized, so they have precision checkpoints, to then allow different tools to quantize with the same schema. Prince from MLX, he did the quantization for MLX. The people from llama.cpp also did their quantization with the same schema. So that's the only important part, is that you're supposed to quantize the model with the same schema as how we did the QAT. That's the theory. In practice, Prince, for example, he did the quantization for other schemas, and he also saw that the quality didn't degrade as much. So that was an interesting learning for us as well, that the QAT was generalizing for other quantization schemas as well. Yeah, maybe I'm going like too deep into these details, but yeah, pretty much we want to enable the community to really monetize for their favorite tools. So let's say that we originally just released the GUFs, so just llama.cpp users could use the QAT checkpoints, and then people were complaining because they also wanted to try out the QATs with MLX or other tools. So yeah, we do want to enable the whole ecosystem.
That's great. I think that's it for the questions. Thank you so much, Omar. We got
Thank you so much.
Brent's next. I'm a heavy user of MLX code because I have a Mac and I bought a Mac with a lot of RAM because the MLX ecosystem is so good. So, Prince, tell us about yourself and how you started doing the MLX stuff and all the audio stuff you've been working on.
Yeah, thank you very much for having me. It's been quite the journey. About a year now working with MLX. I'm a machine learning research engineer. What I do is help companies build and scale their MLOps operations from research to production. And for the good part of last year, I was really deep into MLX, an array framework for Apple Silicon. Imagine it as PyTorch for Apple Silicon, so your MacBooks, iPhones, and iPads. And I've just been building a lot of projects with it and trying to build the local ideal setup to fruition. And basically, today I'm going to talk about MLX audio, and I want to start with a personal story about how this project came to be. I've been in the space of AI for about a decade now, and 5 years ago, which is halfway through my journey, my dad became blind, and he was a really voracious reader. He loved to read books. He would read countless books on end every month. Every day, you would always find him with a book. And when he lost his vision, he could not read paper books again. And I promised him that one day I would build something to help him read and interact with the world again. And this was around 5 years ago. And this year, I pretty much brought this vision to fruition. Okay, so this is the agenda for today. We are going to pretty much go from Omni models all the way to MLX audio and how it fits into the ecosystem. If you notice, majority of the model releases this year have been either vision language models or omni models. But what do you mean by omni models? I'm talking about your text, vision, and audio, and more modalities, as you will soon see. But these are some of the releases from all the big labs, and you can see that all of them, or majority of them, are beyond just the text. And it's the same trend I saw with MLX audio. So I've been working with MLX vision language and MLX LM for a good part of a year. And when I released MLX audio earlier this year, around 70, 80 days ago, I released it. And as you can see from this plot, the community and pretty much users really loved it. And it's just growing like crazy. So within 70 days, we reached more than 15,000 downloads, and we just crossed 2,000 stars in the first 60 to 65 days. And this brings me to the point of this is the year of media models. So you might think of multimodal models as models that can do multiple modalities, but majority of the time, those models output text. But what I'm seeing is that the newest models not only output text, but they also output images, videos, audio, and so on. So these models now produce media content. This is content that you would see on YouTube and many other platforms. That's why I coined it the year of media models. And here's MLX Audio. MLX Audio is the world's first text and speech library for Apple Silicon built with MLX. So one of the core features we offer is text-to-speech, which is what we started with. We allowed users to generate audio from speech. This, in my particular use case, helps my dad read again. So we can take all of his favorite books or books that he wants to read and transform them into audio so that he can listen to them. And then we have speech-to-text. Being someone that is visually challenged, he needs a new way of interacting with the world, because for you to type, you need to really see what you're doing. And with speech to text, it allows him to pretty much interact and voice out his commands either to his phone, which I'm getting him an iPhone later this year, or any other of his devices. And then we have speech to speech. So the idea here is to pretty much consolidate the two core features that I previously mentioned into a pipeline that allows you to pretty much generate or have an interactive voice conversation with your MacBook or your iPhone or any other platform you have that is based on Apple Silicon. And for developers, we are focusing on Python and Swift support, and this is already existing. And on the right here, you can see the pipeline that I'm talking about. And let me show you an example of why this is important. On version 2 of MLX Audio, which was released 2 weeks ago, we announced what I call a modular speech-to-speech pipeline that allows you to use any MLX supported model. So we are talking about your language model or vision language model to have a fully multimodal experience or a voice-to-voice experience. So you can pretty much now create agents that can speak with you. And also on top of just speaking with you, they can see the world as well or retrieve information using tool calling, MCP, or so on. And to show that this is the direction, and I actually started noticing this, there's a huge AI lab here in Europe called QTI. And QTI is a $300 million funded AI research lab, and they're releasing something called Unmute. Unmute does exactly what we released 2 weeks ago, and they just announced it this week or the previous week. So you're going to start to see more of these systems, but if you want to get started, you don't have to wait for them to release their pipeline or their product. You can start today with MLX Audio, and everything is fully open source. And on top of that, one of the really cool things is that with MLX Audio, I took a different approach. I noticed that with current voice systems, the voices are very robotic. They're not very natural sounding. And I wanted to fix that. And one of the ways to address that is with voice cloning. So now you can create voice agents that sound just like you or your relatives, like your dad, your mom, or even yourself. So you can create voice agents that sound exactly how you want it and or who you want it to sound like. And all you need is around 10 seconds of audio. To showcase this, I have these 2 audios here. The first one is Jarvis' voice. I hope the audio works so that you can hear.
Hello, I'm Jarvis. Let me tell you a story about the girl and her cat that goes as far.
I hope you guys could hear that. You could? Perfect. That's Jarvis' voice from the movie Iron Man. I really love Jarvis, and I want to be able to replicate it one day locally. And then the second one is mimicking my voice. I guess you guys have been hearing my voice for the past minute or so. So let's hear how I sound if I was a robot.
Little did you know, her cat Whiskers had a secret. He was the guardian of the map, tasked with guiding Pia.
And that's voice cloning, and this is already available in MLX Audio, and it's coming also to MLX Audio Studio that I'll be releasing later this week, which is a nice interface where you can create voices and use it to pretty much guide your generations. These voices, once created, exist in your computer or in your server forever. So it's yours, and you can generate as many as you want. Now I'm going to show you what the community has built with using MLX Audio. And these are some of the coolest examples I've seen. The first one is by Ben. Ben created this application where he generated 3.5 hours of audio, around nearly 250,000 characters into audio in just under 2 hours on his MacBook. So this runs completely locally. You can generate I saw someone that generated even the entire Bible, audio for the entire Bible, which is pretty cool. And another really exciting part for me in this vision of building Jarvis, which in our case, we are coining it Marvis, my really awesome real-time voice intelligence system. You'll hear more about it in the next couple of weeks, is voice agents. And here you have 2 great examples, one using our modular STTF pipeline in Python, and the other one using Swift. So I will show you the first one with Swift. This was built by RootRank. And this is running completely on the iPhone. So it's using all the iPhone resources to run the language model, the speech-to-speech model, and also some APIs for voice recognition. You can build this today. And the second one is in Python. It's pretty much similar to the previous one, but it uses our pipeline to make things much easier in Python. And this is where, when I start to think about where we are going next, I realize that around 70% of human communication is preferably spoken and not written. So you can use MLX audio today to go change your application and evolve your application to be able to support voice, whether it is on an iPhone, Mac, or iPad. So that's it. I would love to see what you guys build with it. Thank you very much.
Thank you so much. Just in the interest of time, there's a few questions in the Discord. I think maybe we'll do those questions in the Discord so we have time to hear a little about Transformers.js. So we've got native on the Mac, native on the iPhone, and now let's hear from Xenova about the browser.
Sure thing. Let me just quickly share my screen.
In the meantime, Prince, there was a question about what devices you can run the audio models on. What do you need in terms of generation of Apple Silicon RAM to run some of the voice demos you were showing?
Okay, so you can run this as with a MacBook M1 with 8 gigabytes. It just depends on the model that you pick. But most audio models that we support, and actually it's pretty much on pair with what are available. Most of them are around 4 billion max. So you won't see a lot of really large audio models. There are some that are larger, but you don't need them. You can run Kokoro, for example. It's I think 80 million parameter model, and it's pretty small. It's 200 megabytes. So you can run that on your iPhone, I think 15, 14, 13, or older even. So you don't need a lot of resources for that.
Yeah, we've talked about that in some other contexts in the course. It's really fun to hack on audio models, partly because they're smaller and you can do more on your local machine than with most.
There we go. Thank you very much.
Got it.
Hey there, everyone. I'm Joshua, also known as Xenova. This talk, I'll just briefly cover what we're currently working on in Transformers.js, which I am the lead maintainer of. So Transformers.js is our JavaScript library for running state-of-the-art machine learning models in the browser. The goal is to be functionally equivalent to the Python Transformers library. So if you are familiar with the API there, we try our best to make it as similar as possible while being able to take advantage of really great and new web technologies like WebGPU, WebAssembly, and so on, which I'll cover in much more detail a little bit later. So as just some statistics, we're seeing a really great growth of our unique monthly users of Transformers.js models over time. I think the latest number is around 1.5 million. This is out of date by a whole month or two, as things are growing quite quickly. And it's really great to see adoption of WebGPU and WebAssembly technologies over time for running machine learning models. Some more stats, I guess. So NPM downloads in the last 30 days are around over 700,000. And then CDN requests for users that simply load the library via CDNs like JS Deliver, so nearing 9 million monthly requests. So I guess I got just a quick overview of what Transformers.js can do. So we support around 150 different model architectures across a wide variety of tasks, which you can see over there. We typically group them into things like text, vision, audio, multimodality. I'll show a bit of demos in a bit. Yeah, so you can see some general high-level tasks. And we're nearing, I think this number is also a bit out of date, we're nearing around 1,800 ready-to-use models, which users can use by simply like specifying the model ID. And just some benefits of why we like running models in the browser. Number one, of course, let's say security and privacy. You don't really want you sending all your data maybe over a network. You want things running locally. Things like sensitive sensor data, microphone, camera input stays local. And that also means that you don't have to, there's low bandwidth requirements for users that maybe need to send real-time video. That doesn't seem very likely, sending real-time video over a network, which allows you to create real-time applications due to this low latency and no need for a network hop. And then lower costs both for users and for developers. So developers don't have to host their models like on a separate GPU instance. We can leverage the user's GPU. which allows us to distribute and showcase our models and demos in a way that doesn't bankrupt you because we're using the user's compute. And for a user, you don't have to pay or sign up for anything. Everything can just run locally in the browser. And the last one, of course, is due to the web's nature, it's highly scalable. Just literally just send a website link and people can reuse and run your models. So yeah, let's just a quick overview of that's now that we're done with a quick overview, just to showcase how to add and run models using Transformers.js. The goal is to make it as simple as 3 lines of code. You import the library, you create a pipeline, and you run the pipeline. And as I mentioned before, we support around 25 different tasks. So you can specify, for example, specifying instead of sentiment analysis, you can say, let's say background removal or text to speech or speech to text, something like that. And yeah, you can specify the task, custom model if you'd like, over the let's say 2000 models on the Hugging Face Hub. And yeah, I'll showcase a bit of that a bit later. And then, of course, if you want to run, let's say LLMs, you can run different precision models, FP32 or Q4, as VB and others have spoken about earlier with quantization. And you can also run either choosing if you want to run on WebGPU, so GPU, or WebAssembly, so CPU. And we also have experimental support for WebNN, which allows you to run NPU, GPU, and CPU in the browser. And as I will showcase in a bit, we have growing and increased support for WebGPU. It's, for those unfamiliar, it's basically the WebGL successor and is meant to provide better compatibility with modern GPUs. Also, it's meant to be more general purpose. So I guess WebGL was more for graphics, but WebGPU is now enabling far more general compute, and that is great for machine learning. And it's growing in usability and support across browsers. I believe the latest number is around 75% support for users of browsers, but that doesn't account for, let's say, as VB was mentioning, so sometimes in Safari, it could blow up or something doesn't work quite as well. But Chrome, I would say, is pretty good support. Firefox is getting there. Safari is getting there. I guess all Chromium-based browsers, so Edge, Chrome, Brave, all those browsers, typically quite good support. And then also, as I just briefly mentioned, we have support for different quantizations. So if you want to reduce computational and memory costs, you can decide to use a model of lower precision. And this is essential for web applications due to its resource constrained and their resource constrained environment. And of course, this is specific to the model. So in this case, it's a vision model that I'm showcasing. Sometimes it can be quite sensitive to quantization. We've seen pretty decent support for this, which I'll showcase in a bit. And yeah, just other factors to consider whether you want to, what's better, speed, accuracy, how much bandwidth the user has to download. No, they have to download the model once, but it's still important to choose a low enough size. And then after they've downloaded it once, it's cached and they don't have to download it again. And then also device features, things like, what do you need? Do you need to use browser APIs like the microphone or, let's say, screen recording or anything like that? And then, of course, if you're trying to run on desktop or mobile, it alters what you're able to run. So what I'll quickly do is switch over to a new tab, which you can hopefully see here, just to showcase some of the demos we've created. I'll go through these quite quickly. I don't want to waste too much time. But we have running Whisper in the browser, so as you can load an audio clip and it'll run pretty decently. It's 80 or so tokens a second. That was for 1 minute audio running on WebGPU. Next one, I guess like a real-time running Moonshine in the browser. So I guess we can enable, hey there, how are you doing today? Yeah, there we go, pretty good. And we can also skip to another model, Kokoro. So Kokoro is a new open weight model, and it's quite parameter efficient. So in this case, around 82 million parameters for really high quality speech output. And it also supports a variety of voices. So we'll just click generate, and I don't know if you can hear that, but if you can't hear that, then that's fine. It's just playing in the background. It's a pretty decent audio output, which you can play around in your own time by visiting this link. Next up, we have background removal. You just upload a video or upload a series and you can remove the background. This is a really great example of where WebGPU and in-browser inference can really help, because you have to send all your data elsewhere to do processing, and yeah, significantly reduces costs there. This was another running a Janus Pro for a bunch of different tasks. Actually, this is one of the models that supports a variety of tasks. So it's like image generation. Okay, spit it up a little bit here. There we go. You can also do image to text. And this is the LaTeX generation, works pretty well. And then, of course, the standard text to text. Next up, oh yeah, this is just showcasing the model running. So I'll just click an example. So this one's running like right now, running pretty well, like 100 or so tokens a second. In browser, this is a 1.7B model, so decently sized. And of course, we have support for all the latest models, like the new Qwen 3 models. This one works pretty well as well, around 100 tokens a second. And let's go to the next one. This one's for image editing. So segment anything running in the browser. You can click it and cut the mask to, let's say, if you want to have a Figma plugin. There we go, downloads that. This one's, yeah, real-time in the browser. I showcased this, but this one is now using Whisper. Hello there, how are you doing today? My name's Joshua. There we go, pretty good. And let's see. I see we have quite a few left, but I'll quickly go to this. So let's just type in. This one's for semantic search. So let's say if you want to have a database of images. So this one's a cat, I don't know, desert, landscape. Let's see what pops up. There we go, pretty good. So semantic search in the browser. Next one, semantic audio search. I realize we've got too many demos to show. Let's say calm harp music, I don't know. And then it shows this. There we go. Oh, very nice. You can't hear that, but it's really calming. I'll skip some of these other ones. This one's like music generation, which is pretty good. I guess you can't hear that. This one's real-time depth estimation. This one is quite cool. Someone created like using the depth estimation model and then added it to their Apple Vision Pro. It's pretty sick. So you can view images in a better 3D environment running with thanks to Transformers.js. Then I guess the last one I'll showcase is someone decided to remake this one from the movie Her with Transformers.js. So it's like a real-time speech-to-speech. So you can't hear it now, but basically just asking. It asks you like, hey, what's your name? Then you give it the answer, and then it'll cache that in a separate embedding model, and then it can retrieve that later to give you a better personalized experience. And yeah, pretty much that's it. The rest of the slides are just like showcasing some other demos. But yeah, happy to answer some other questions, or maybe the last one, because this one was someone asked this a bit earlier, showcasing computer use in the browser. So this one is basically running a model called OmniParser, and I'll just showcase the console so you can see it logging output. So you give it like a screenshot, or it works on screenshots, but basically just give it any browser input, and it'll basically identify parts of, so it identifies all these icons. And then this will then be sent to an LLM to then be able to do further generation. I don't know, click the sign in button or something like that. Yeah, this is also running in real time now. Yeah, I think that's pretty much it. Happy to answer any questions.
That's fantastic. I think we have to stop just because we're a little bit over time and we have another session. But would you be willing to share the slides or a subset of the slides, because people really do want to play with the demos, follow the links?
Yeah, I have to like a subset of them, but I can share that.
Yeah.
I can also share like a bunch of links and stuff like that.
That's perfect. Send them to me or put them in the Discord, whatever's easier for you. But people are blown away by those demos and by all the demos this session. So thank you so much for the guests who came to help us get up to speed on local models and all the cool stuff going on in these open source ecosystems. And thank you to everybody. I will probably see some of you in a few minutes for the Weights and Biases experimental Gemini as a judge session. Thanks, everybody.
Cool. Cheers, everyone.